All right, and we're live. Welcome, welcome. Let me just copy a link to the stream. If I can even. Yes. Oh no, we're reading a book? Yes, we are. We are indeed reading a book. If you don't, I mean, again, I can switch it up if you don't like it, but we're reading a book. I'm also gonna have a terminal open too to screw with things. I'm also gonna, we'll see. Again, this is just a test stream. Wait, you haven't done C in Uni? Yeah, I have. So I'm gonna like probably skim a book. Let's go. Yeah, exactly. So this is just kind of to test too. I just want to see if I even like this. But yeah, I have a bit of C experience. I just thought it would be kind of an easy stream to get started with. But yeah, welcome in, guys. This is, members only stream. Pretty exciting stuff. Let me open up a terminal as well. That is not what I wanted to do. We'll zoom this guy in here. So we'll have this terminal open too. Okay, I'm happy with skimming stuff, feeling so elite. Yeah, I'm not gonna like read every single, I'm like, especially at the beginning. For the harder stuff, like for sure, I'm gonna go into like details. But I'm also gonna be live coding on the side too. I think I made a programming, what did I call this folder? Learning C. There we go. Okay. I'm at work, so I won't be able to chat much, but I'll be here. I appreciate you, Salty. Appreciate you joining and supporting. It's going to be kind of a chill stream. Again, this is just an inaugural members-only stream, so, if we don't like this, then we can move on from it. This is just kind of the beginning. So, yeah. Let's begin. So, I have done C before. I've built some things in it, but I would actually I think it would be really cool to actually build, you're already privileged, yes. I think it'd be really cool to actually build like legit projects in C sometime, like whether it's like an HTTP server or something like this, like doing code forces or whatever in the future, but yeah, that's the plan. Maybe I'll do a couple public streams as well, like of this later down the road if we like it. But you're still gonna do a normal stream after this? Not today, Salty. This is all I've got time for today. Next normal stream is scheduled for Wednesday, but I might move it to tomorrow. I'm not sure. And I might move Wednesday's stream to tomorrow. I'm not sure yet. But yes, this is all I've got for today. But I will be live the normal amount of time, so I'll be live until about 3:30 my time. So we're gonna do 5 Palmos just like usual. But yes. So C programming language was pioneered by Dennis Ritchie. Okay. It's just because until the time C compilers were not readily available. Okay. Yeah, do like a day 5 stream publicly so people know what they miss out on. Yeah, exactly. I'm gonna do I'll do like sneak peeks for sure. So initially C's growth and popularity was also spurred in part by the equal popularity of Unix. So C and Unix kind of grew together, it seems like. And again, it's kind of cool to get this little history. I chose this textbook mainly because I don't know, I spent some time kind of going through what I thought was good, and I wanted to use a textbook that hasn't really been used before, on streams. So I chose this one. And the name, the exact name for it is in the description if you want to Google it. So yeah, all I'll say is you can find it for free online. I'm not going to say where, because I don't want to It's technically illegal, but you can find it for free. The way I'd skip this and immediately get into the code, two types of people, I guess. Yeah, fair enough. I would also advertise the extra stream somehow to help promote membership. Yeah, exactly. I need to, honestly, you guys, again, are like the guinea pigs. I haven't fully, like figured out exactly what my membership strategy is. So this is kind of like I appreciate you guys bearing with me as I kind of do this, because this is the first time I've ever done something like this. So, you're the privileged few that get to kind of work with me during this process. And because you're early, you also get to have a lot of say in what goes on. Usually live streams using C programming, a modern approach. Yeah, that's what I thought, but this one's a little more modern. So that one, full stack, is from 1998. We're here for the ride. Appreciate you guys. That one's from 1998. This book was published in 2014. So it's a little bit more modern, which is why I went with it. So, I mean, I know 2014 is like still kind of out of date, but, it's more modern than the late 90s. So, and the good news with C is my understanding is it doesn't really change that much. Like, sure, it's changed since the 90s, but, year by year, it's nothing crazy. So we can do, I think there's like highlighting features, yeah. Okay, so we can do like highlighting. Let's do like blue highlights or something. Can I like close this menu? Yeah, okay. If we want to. My name's Marco. If username feels weird to you, I don't really mind. All right. Well, nice to meet you, Marco. Sounds good. I will remember that. I just call people by the username. But yeah. Okay, so let's see. Again, we're just going to skim this here. The enormous success of the IBM PC and its lookalike soon made DOS the most popular environment for the C language. And then there was I know of this textbook too, the C programming language. That's like the quintessential textbook. This one. This guy. This is like the one. This is like basically the Bible of CS. Ugh, school again, yeah. But it's okay. We're gonna, we're just gonna go through this. It's learning the hardcore way, In the early 1980s, a need was seen to standardize the definition of the C language. Okay, so they made ANSI C, American National Standards Institute. Okay, blah blah blah. C is a higher level language. This is kind of funny that they describe this as a higher level language. Yet it provides capabilities that enable the user to get in close with the hardware, mostly because of syscalls, yeah. This is because although C is a general purpose structured programming language, it was originally designed with systems. Also, so if you're a non-member, you can see the thumbnail and that you're live at the moment. That's cool. Yeah, I think so. Might entice people to spend money. Hashtag capitalism. Yep. Is there a certain project you're looking to build? Honestly, I think my understanding was I think there are like, I kind of skimmed this book a little bit. But if we go through it, you can kind of like, I think there are, like I can kind of code along with it. But the other thing I can do is, look up, like, so there's some exercises that I can go through. DMC, yep. Pre-read? Yeah, no, I'm looking through this. So there's some exercises we can do. And I don't know if I'm going to do all of them, but there are exercises. So that's kind of the idea, is just to get started. But it would be cool to build like a legit project eventually. And I don't even know like what I want to build yet, to be real. I'm going to kind of figure it out with you guys as we learn. But yeah. And also, this is the first time I've done a non-web dev stream, so kind of bear with me, I guess. This book proposes to teach you how to program in C. It assumes no previous exposure to the language. Yeah, so I went with an easy one specifically, just because I didn't want to like jump into something that was a little too complicated. But it was designed to appeal to novice and experienced programmers alike, which is good. Road to learning RE soon. What does RE stand for again? Like reverse engineering? Is that what you mean? Yeah, that's what I thought. Yeah, maybe. I'm also just like, on top of learning C, like I'm here to just chat with you guys too and hang out. you know, this is also for you to kind of just hang out and chat. I might also make like a maybe for the next stream, my next membership stream, I'll do like an open voice chat or something. I don't know. So yeah. This reflects the overriding philosophy that has been used to writing this book. Teach by example, which is good. I do like this generally. If you have access to a computer that supports the C programming language, you're strongly encouraged to download and run each program presented in this book. Yeah. Amazing feature for socially awkward bunch of us. Yeah, that would be cool. Yeah. I'm thinking of doing that. You'll find that program readability has been stressed. This is because I strongly believe the program should be written so that they can be easily read. So that's good. This book is written as a tutorial, which was the other reason I went for it. Material covered in each chapter is based on previously presented material, which is good. So we're going to kind of like stack our knowledge as we go. Maximum benefit will be derived from this book by reading each chapter in succession. And you're highly discouraged from skipping around, see? You should also work through the exercises that are presented at the end of the chapter before proceeding. I'd actually be careful with letting people on stream because they can misbehave. Build rapport first. Yeah, well, no. I'm talking specifically for members, supporters only. So maybe like if you've been supporter for like however long, but like I trust all you guys. Like KC, you've been a supporter for a while. I think out of the 4 of us members, we aren't getting up to anything bad. Yeah, exactly. Like I trust each and every one of you in here. So members can still misbehave. Yeah, no, they absolutely can. I agree. But like you guys have all been viewers of the stream for weeks and weeks, if not months at this point. So, you know, I trust you. I trust you guys. You wouldn't trust you? Yeah, nah, don't worry about it. Always stay vigilant. Yeah, exactly. Because you can get screwed over easily. I think, for sure. I feel like though, as I've done stuff on the internet, I feel like I've gotten a pretty good radar for, you know, detecting people that are, you know, misbehaving and such. Okay, let's read. So, some fundamentals, which covers some fundamental terminology about higher level programming languages and the process of compiling programs. Oh wait, I didn't mean to click that link. Oops, hold on. Let me go back to it here. Compiling and running your first program. Once you be slowly introduced to the C language, by the time chapter 15 rolls around, all the essential features of the language will have been covered. We got some advanced features, debugging programs, which is good. Over the last decade, the programming world has been abuzz with the notion of object-oriented programming. C is not an OOP language. Gives a brief introduction to OOP, and then so basically just kind of going over what things we've got here. So some fundamentals. So let's also take some notes. So it's called fundamentals. All right. And I'm going to kind of showcase as well, like this is also, if you're still a student or what, this is kind of the process that I would go about when I would study as a student. So maybe you guys could take value from that and, you know, maybe, I don't know. But this is kind of like what I would do. So this chapter describes some fundamental terms. A general overview of the nature of programming in a higher level language is provided. Yeah, so computers are really dumb. See, AI is dumb too. Because they do not only do what they are told to. Most computer systems perform their operations on a very primitive level, which I think is important to keep in mind when you're doing these things. I need to like figure out how to have this menu. There we go. Most computers know how to add one number or how to test whether a number is equal to 0. Like kind of like assembly instructions. Computers can move values around, add values to other values, and test whether a value is 0, for example. You could just remove the pages on the left. No. Yeah, I think I can. Yeah, if I click, is it this? There we go. That's it. Even when our machines are told what they do, they still get it wrong sometimes. Computers never wrong. Humans are faulty. Yes, technically. I think you're right. The sophistication of these basic operations usually does not go much further. Basic operations of a computer system form what is known as the instruction set. Yes, so that's obvious. These all form the instruction set. And again, this is kind of like a review of, okay, but what note-taking app? Yeah, exactly. Bruh, that's so true. So yeah, again, this is gonna be kind of a review of my CS stuff, but I think it's good to go through it because I'm kind of rusty on C anyway. Solve a problem using the computer, you must express the solution to the problem in terms of the instructions. Solutions to problems should be in terms of the instruction set, right? Computer program is just a collection of the instructions necessary to solve a specific problem, of course. The approach or method that is used to solve the problem is known as an algorithm. Yeah. Solutions to problems should be in terms of instruction set, and these solutions are algorithms, right? For example, if you want to develop a program that tests if a number is odd or even, the set of statements that solves this problem becomes the program. And the methods to solve these problems are algorithms, and which are implemented as a program. There we go. Yeah, let's assess how good of a programmer he actually is. Yep. Spoiler alert, not a very good one. Normally, to develop a program to solve a particular problem, you first express the solution to the problem in terms of an algorithm. Yeah. First express the solution to a problem in terms of an algorithm and then develop a program that implements the algorithm, right? I basically just said that here. So the algorithm is for solving the even-odd problem might be expressed as follows. First, divide the number by 2 if the remainder of the division is 0. Number is even, otherwise it's odd. And then with the algorithm, you can write the instructions necessary to implement, of course. When computers were first developed, the only way they could be programmed was in terms of binary that corresponded directly to specific machine instructions. Yes. Development of assembly languages which enabled the programmer to work with the machine on a slightly higher level. The assembly language permits the programmer to use symbolic names to perform various operations. So let's say levels of programming languages from lowest to highest. And so the bottom is machine code, which is direct binary. Like literally direct binary. Corresponding to specific machine instructions and locations in the computer memory. Assembly. Wait, did you say you're learning C specifically? You want to dive into system software, server, and networking stuff? Have you mentioned you want to turn this into a project and make an HTTP server? Yeah. Well, I only mentioned that as an example, Marco, because that I saw somebody doing that and I thought it was kind of cool. Patiently waiting for the day one of learning assembly until I give up. Yeah, could be next. Could be next. We're just gonna keep going down the ladder, and then sooner or later, I'm gonna be programming my own 8-bit breadboard computer with dip switches. Like I don't know if you guys have seen Ben Eater, but that guy's like the goat of that type of thing. We need to go lower. Yeah, exactly. But Ben Eater is insane. So that guy's cool. Permits, or abstracts, I should say, abstracts machine instructions as symbolic, or abstracts machine code into symbolic representations to perform various instructions. And then we can say the assembler converts the assembly code into machine code that gets executed on the computer. Gets executed, I guess. It doesn't really matter. And then we should also say has a one-to-one correspondence with machine instructions. I think. Day 2, I gave up. I'll be annoying and ask you to move to the chat at the bottom middle because it's blocking the book. Oh, okay. Good idea. Let's move the chat. Hold on. I think I locked it. Let's put the chat here. There we go. Much better. How's that? I could just hide chat from member streams. Yeah, that's the other thing. I could also do that. I mean, I'll move it to the middle. If you guys don't like it there, I'll hide it. But I think it's fine there. Unless you have any qualms. Okay. Yeah, actually, you know what? Let's just hide it, to be honest. Let's move it back to where it was, just so that it's there. For next time, for the public streams. Where is this? Like here-ish. Okay. There we go. He feels less alone when he has the chat on screen. No, I got you guys right here. Don't worry. But it is true. It is true. You guys are my... I consider you, each and every one of you, my friends now, so... Okay. So, yeah. Assembly languages are regarded as low level and are thus regarded as low level. Programmer must still learn the instruction set of the particular computer system to write a program, not portable. Program is specific to the processor it's written for. And then so an example would be CPUs that use x86, right? Or ARM, or is it ARM? I think it's ARM, etc. These sort of things. I did it, Mom. I made a friend. Yes. No, honestly, it's great to have you guys. But yeah. Yeah. So machine dependence. You guys probably think that I have a bunch of friends off stream. I really don't. You guys are my friends, you know. I don't really all the friends that I had from high school and stuff, I don't really talk to them much anymore. It's kind of sad, but I guess that's just the way things go. I genuinely didn't think that. Fair enough. I don't know. Yeah, I don't know. I'm the same way. I have work pals, but that's it. Yeah, exactly. I mean, I'm friends with my coworkers for sure, but it's not the same. So And I mean, yeah, like there's a different, like understandably you came to the real programs, yeah. And I think like it's important, especially as you get older, to surround yourself with like-minded people, right? Um, I mean, you have a girlfriend, so that's double. Yes, I do, and I love her very much. So she's taking a nap right now. But yeah, no. Honestly, yeah, I have a girlfriend. I have my family. I have her family, and I'm really blessed, honestly. Like, so, um, yeah. Okay, then along came so-called higher level languages, Fortran. I have a limited number of friends, but they're very good friends that I can count on. Yeah, that's awesome. More people just exhaust you. Yeah, and I'm actually, you guys probably, I don't know, I'm actually like an introvert, like pretty heavily introverted. And I did the streaming kind of also to come out of my shell a little bit, which I think it's kind of helped with that. But I am like by nature very introverted. Yeah, Fortran. So yeah, like higher level languages. So, and then it basically abstracts various assembly languages into a unified standard set of instructions that can run on many different architectures. Yeah, streaming is a great way to get out of your introvert comfort zone. Yeah, exactly. I remember seeing a video some time ago where it explained how many friends you can actually remember in your brain. Yes, it's about, I actually, fun fact, I took an anthropology class in my first degree, and I remember we learned about that. It's like kind of like, I think it's around 150. You can't remember the details and be good friends with more than 150 people, which that still seems like a lot. Like, I mean, I've only got, like, in my inner circle in my life, I've only really got, like, maybe 6 people. Like, 5 or 6 people that I would consider, like, really close. So, and maybe, like, yeah, like, probably 5 people. You know? So, like, the fact that, like, you could technically have, like, up to 150 is crazy. I got my GF and around 5 close friends. That's awesome, Casey. I have a couple close friends. I don't even really know if I would say I have that many, maybe like 2 or 3 at this point in my life. I used to have more. I used to have much more, like in high school and stuff. I had a little circle of maybe like half a dozen. Damn, 2 programmers in the same room that have a GF, yeah. Well, it helps that like my girlfriend's in tech as well. I mean, she's in more like the design side, but she's in tech. All right, let's take our break, even though, I don't mind because managing time with all the friends and a girlfriend on top can get tricky. So 5 is more than enough. Yeah, I agree. But yeah, I think it's about 150. It's like but there's like various degrees of closeness that you have to people, right? Like you've got your inner circle, and then you've got like a little like an outer circle, and then you've got like your acquaintances, and then those like grow. I think you should Pomodoro this properly and sporadically pay attention to the chat during 25 minutes and then react during chat during breaks because this will get you distracted. Yeah, fair enough. As clearly is the case. Yeah, fair. Okay, got you. I want to like make sure you guys are entertained at the same time. I don't know. I don't know. I want to make this engaging at the same time. So, but no, I'll lock in after this break. But no, generally speaking, that is a good thing to say because the streams, a programmer entertainer, yeah. Well, because I mean, you guys are paying money, right? Like, I want to make this enjoyable for all of us, right? So, I don't know. And again, we're figuring this out. Like, this is the first time I've ever done anything like this. So, we're all learning together what, the flow of this is going to look like. But yeah. What was I going to say? Yeah, I think it's important to have those people close to you, but also, have your acquaintance or just the Pomo during. Just it's the Pomo. Yeah, I could. It could be like any other stream. We willingly pay money to support you for your other normal streams. That's fair. No, that's fair. That's fair, Marco. So good to have some background noise. Yeah, the only reason I do the Pomo anyway is just to kind of like keep track of like how, um, how long the stream's been. And it kind of like forces me to take a break. So I mean, I'll do it, but like, you know, I don't think we have to be super strict about it. I do it not to burn out. Um, yeah, fair enough. Yeah. Yeah, I think because the other thing too is like I was noticing like the reason I brought in the Pomodoro timer was because I found like during my early streams like I'd be really tired after, and it was because I wasn't giving myself a break. And I think as my audience grew and stuff, like I think the Pomodoros really helped me feel like this was a very structured thing. Like it almost feels like when I stream to like the world, I kind of like treat this mentally as like a part-time job. And I think that's really helped me take this seriously. Like it's kind of like a mental shift. Um, Instead of treating it as like a hobby, you like take it seriously and treat it as like a serious thing. I think we can all agree that when we first started to get into tech, we endeavored into 8-hour sessions of hard learning without breaks, which is ruining. Yeah, exactly. I've been there, Casey. I was when I was at the beginning of my CS degree, I almost burned out by doing that because I was so interested in the course content like at the beginning that I would like literally just study and study and study. And yeah, and it was around January of my first year, or December I should say, where I was just like so like I was like, okay, I gotta have a better balance here. And even as a kid, like when I was learning like Game Maker to do game development, I would work, come home from school and just work for like hours and hours and hours. First time seeing HTB, I was like a kid at a playground. Yeah. I think I think there's also I think the emphasis on like hustle culture and stuff. This is just a general opinion I have, but I think the emphasis on like hustle culture and like working yourself to almost not death, but like working insane is a little silly. I kind of like the idea of deep work though. I've heard of that concept used, where you like kind of work very intensely solo for like 2 hours, but you just really lock in. I think that's more productive than working for 8 hours. Okay, all right, time to work. Okay, higher level languages, of which the Fortran language was one of the first. I think Fortran came out in like the 50s or something. One Fortran instruction or statement resulted in many different machine instructions being executed. So yeah, so that's the other thing. Is okay, so we'll say one what is it? Instruction may translate to a various or to a many multiple different or multiple assembly instructions. Somebody types, no, it's okay. One instruction may translate, don't worry, I'll just ignore you guys. I'm just kidding. Okay, so one instruction may translate to multiple assembly instructions. How many it translates to depends on the number of, or depends on the assembly language being, depends on the assembly language, I guess. Standardization of the syntax on a higher level language meant that the program could be written in the language to be machine independent. Yeah, so machine independent. Program can run on any machine. Support a higher level language. A special computer program must be developed that translates the statements of the program developed in the higher level language into a form that the computer can understand. So. And then this is the compiler, yes. The translator between the HLL and assembly is done by a compiler. So, operating systems. Before continuing with compilers, it's worthwhile to understand the role that is played by a computer program known as an operating system. Yes. Operating system, program that controls the entire operation of a computer system, obviously. The operating system must also manage the computer system resources and must handle the execution of programs. So, manages system resources, handles, if I could type, and also, among other things, booting. What else does it do? I don't know, disk utilization, etc. Okay. One of the most popular operating systems today is the Unix operating system. I don't know if today is the right. I guess if you think of Linux and Mac as Unix. Historically, operating systems were typically associated with only one type of computer system. But because Unix was written primarily in the C language, the most popular, one of the most, and then Unix was written primarily in C, which was groundbreaking because it made very little assumptions about the computer architecture it was running on. Thus, it could be ported to many different machines with varying architectures. And that actually did not know. I did not know that Unix was written in C. Of more recent vintage are operating systems that were developed to run on portable devices such as cell phones and tablets. Apple's iOS and Google's Android operating systems are the two most popular examples. Compiler analyzes a program developed in a particular computer language and translates it into a form suitable for execution on your particular computer system. The compiler is specific to the HLL and the assembly language being used. Is written to be, I think. Figure 1.1 shows the steps that are involved in entering, compiling, and executing a computer program, and the typical Unix commands that would be entered from the command line. So we edit the file with VI, compile and assemble. If there are errors with the, the compilation, I guess it outputs those errors, right? This generates the object file. I remember all this stuff. And then after that, you need the linker for the libraries and other programs, which is good. So steps of a compiler. Steps of compiling a C program. So, a C file, e.g. file.c, is compiled into and assembled into an object program. Called file.o. If there are errors, return those errors. The compiler will return those errors to standard out, I think. I think this is right. Otherwise, the linker will run. The linker will take the object program and create an executable object, a.out. By linking other libraries and other objects programs in a.out. Okay, so if the results of the linking are good, then a.out can be executed and run, or I guess executed is running, can be executed, otherwise an error will occur and the programmer will have to edit their program to address these. An example would be like not, or referencing a library that does not exist, or something like this, right? So that's good. So let's see if this kind of matches what we've got here. So the program that is to be compiled is first typed into a file. Computer installations have various conventions that are used for naming files, but in general, the choice of the name is up to you. C programs can typically be given any name, provided the last two characters are .c. So a text editor is usually used to enter the C program into a file. Vim is a popular text editor used on Unix systems. The program that is entered into the file is known as the source program. So the program in this file is known as the source program, expressed in the C language. The name of the file that contains the source program must also be specified. For example, under Unix, the command to initiate program compilation is called cc. If you're using the popular GNU C compiler, the command to use is gcc. Okay. The source program is named before a compiler as a command to be run to compile. E.g. gcc file.c, right? So typing the line gcc prog1c has the effect of initiating the compilation process with the source program. In the first step of the compilation process, the compiler examines each program statement contained in the source program and checks to ensure that it conforms to the syntax and semantics of the language. Okay. So compiler checks that the C language, there the source conforms to syntax and semantics of C. If errors are found, compilation ends and errors are returned to user, or programmer, I should say. If any mistakes discovered, yes, they are reported to the user, and the compilation process ends right there. The errors that are, then have to be corrected in the source program. Typical errors reported during this phase of compilation might due to an expression that has an unbalanced parentheses, or due to the use of a variable that is not defined. Example errors using an undefined variable. Invalid syntax. Missing a semicolon or malformed statement, etc. When all the syntactic and semantic errors have been removed from the program, the compiler then proceeds to take each statement of the program and translate it into a lower form. Pre-processing phase. Okay. This is also known as the pre-processing phase. Okay. See chapter 12. Good. On most systems, this means that each statement, okay, yeah. If after the program has been translated into equivalent assembly language, okay, yeah. So then that's the next step. So compiler or translates the program, gets translated into assembly by taking each statement of the source and and generating corresponding assembly instructions that accomplish what the source specifies, right? So that's good. After the program's been translated into assembly, then it needs to be assembled, of course, right? The next step in the compilation process is to translate the assembly language into actual machine instructions. Yeah, so then the generated assembly gets assembled into machine instructions that are executable on the hardware, right? On most systems, the assembler is executed automatically as a part of the compilation process. The assembler takes each assembly language statement and converts it into a binary format known as object code. So the generated output of this is the object program containing the binary representation or binary machine code representing the program, the source program, right? So that's good. So this file typically has the same name as the source file under Unix with the last letter an O instead of C. After the program has been translated into object, it is ready to be linked. All right, so the process is once again performed automatically whenever the CC or GCC command is issued. The purpose of the linking phase is to get the program into a final form of execution on the computer. So example programs that are used from the system programs library are searched for and linked together with the objects program during this phase. The entire process of compiling and linking a program is often called building. Yes. Compiling, then linking. So it's kind of, it would be pre-processing. Compiling, linking, execution. Something like this, right? So the entire process of compiling, linking, yes, is called building. Final linked file, which is an executable object code format, is stored in another file on the system. The file is called a.out by default. Under Windows, the executable file usually has the same name as the source file, except with exe. Subsequently execute the program. All you do is type the name of the executable object file. To execute, just type the name of the executable in the command line. I keep misspelling executable. In the command line. And it will run, assuming it has execution permissions. Okay. So like the RWX permissions, right? Each of the statements of the programs sequentially executed in turn. If the program requests any data from the user known as input, the program temporarily suspends its execution so that the input can be entered. We know this. Simply wait for an event. Results are displayed. The program knows output appear in a window. Yeah, so this is all kind of obvious stuff. Debugging phase, during which attempt is made to remove all the known problems or bugs from the program. Good. The individual steps involved in developing C programs were outlined earlier, showing typical commands that be entered for each step. The process of editing, compiling, running, and debugging programs is often managed by a single integrated application. But we don't use IDEs, right? We use text editors. So you can use an IDE to manage all steps of writing C programs, which would be editing, compiling, running, debugging. So that's fine. Before leaving the discussion of the compilation process, note that there is another method used for analyzing and executing programs developed in a high-level language. With this method, programs are not compiled but interpreted. Interpreters. Analyzes and executes statements of a program one line at a time, or one statement at a time. So like in the, so it kind of like goes through and like, I guess it kind of, you know, iteratively compiles as it goes, or it interprets, I guess, would be the right terminology. instead of compiling the entire program first. Usually allows for easier debugging for the programmer, right? On the other hand, interpreted languages are typically slower, run slower than compiled programs because of the interpreter overhead, right? i.e., statements are not converted into a low-level form prior to their execution. Basic and JavaScript are two programming languages in which programs are often interpreted. Other examples include the Unix system shell and Python. Some vendors also offer interpreters for C. Interesting. Very cool. So I think that's like basically it for that. All right, so compiling and running your first program. Very cool. So let's make a new note. So we'll say, let's just say first C program. Making a C program. Let's just call it that. I actually probably want to put the chapter first, so that's easy to find. And they'll be in order, so we'll do that. So in this chapter, you're introduced to the C language so that you can see what programming and C is all about. So, what better way to gain an appreciation for this language than by taking a look at an actual program? All right. Writing your first program, modifying it to change its output, understanding the main function, outputting information with the printf function, improving your program's readability with comments. To begin, you'll choose a rather simple example. All right, so let's write this program here, guys. So I'm gonna do like a programs, and then cd programs, and then we're gonna do a vim. What are we gonna call it? prog1.c. Okay. Let's just write this real quick. So include standard io.h, which is the standard library, into main, void, printf, and then we'll say BenStack's first member or supporter stream, or hello. And then we have to return 0, of course, to indicate that it was successful, right? So that's good. Love the focus session. Thank you. Appreciate that. All right, so there's our language, or there's our program, right? So if we do cat prog1, there's our program. Cool. See, much more productive. Yes, indeed. Hello, hello, hello. I hope that was kind of insightful for you guys to see. That's kind of like how I would study, and I would do that for a few hours every night when I was in my degree. I mean, I wouldn't talk to myself maybe as much, but it is helpful to kind of talk through it. I will say. Yeah, I mean, I did I don't mean to self-glaze, but I did get fairly decent grades. This is exactly how I'd study history as well. Yeah, exactly. I also need to make a better dot file for my Vim, because my Vim config is kind of shitty. If I go to my, do I have a VimRC. Do I have a VimRC? Yeah, I do. But it's not very good. That's okay. But you did much better than me. I tried uni and quit. Yeah, that's fair. I mean, it's not for everybody, Salty. It's the way that you learn in university is that kind of style. It doesn't suit everybody's style. And I totally respect that. Like, I grew up in a family where like my mom's European. Very like education was always very important. So both my parents. Well, my mom was a teacher as well, so like very very important. So I kind of was like ingrained, I guess, from a young age to do well in school and these sorts of things. I got tired of not making money and just wanted to start a career. Yeah, I got that at the end, to be honest with you. Like, my younger brother actually is in a PhD program and he's only 22. So like he like really is grinded on school. And like, both my parents also have higher level education, like, beyond undergrad. So I don't know. There was kind of this like sense that like we had to go to like, masters, PhD, these sorts of things. But I kind of was like, I did my 2 undergrad degrees and I'm like, you know what? Like I was 24. I was like, I'm done. I want to, start working. Or actually I was 24. That's right. And so I just was like, yeah, I'm going to get my CS degree and start my career, which I did do. I started working a little over a year ago and, I mean, making money now, which is nice, but, there was always an emphasis in my family of like, education. And my brother decided to go down that path. I tried, like I thought about it and then I was like, nah, not for me. So yeah, again, I don't really think, it's also the other thing too, is like, there's too much pressure on kids, I think, to have it all figured out by the time they're like 17, 18 years old. And like, I didn't really know what I wanted to do until I was like 21, 22. I got tired of not making money and started making it. Yeah, exactly. Yeah, and it's like, I don't even like, I make like pretty, like for working in tech, like I kind of make like shit money. But I don't even care. It's enough that I can like live on my own and pay for my living expenses, right? Like, I mean, am I like rich by any means? Absolutely not. But I can like scrape by, maybe not scrape by, but it's not like I, basically all the money I make is, I don't really have much extra I can save. I save some every month, but it's not like a lot. It's like usually it's about like 10%. It's like 10% of my income I try to save. As long as you can pay for a streaming station that involves a PC, microphone, a webcam, I'd say you have enough. Yeah, exactly. Yeah. No, I try to put away like 10% of my income, into like various like savings. Like I invest some of that, and I also put it away into like retirement plan, these sorts of things. Yeah, the pressure to have everything figured out is bizarre. There's no way to experience anything with the pressure. Yeah, exactly. Like, and it was weird because like I started my, like when I was like into halfway through my second year of university, doing my biology degree, and then COVID hit, right? And I'll get started in a sec. I just want to finish this thought. But like COVID hit, and I was like, it kind of just threw everything through a loop. Like I was kind of set to go down this path, and then like the world ending for like a year, or like seeming to end, kind of like made me rethink my entire life. And that's kind of why I pivoted toward tech, because I was like, you know what? We only live once. We should do things that we enjoy instead of kind of feeling like that we're, being siphoned into a path. And, that's kind of what led me to where I am today. So anyway, let's begin. So I need to actually, I don't even know if I have GCC in here. Okay, so I do. It is on macOS by default. Okay. Very cool. So in the C programming language, lowercase and uppercase letters are distinct. It does not matter which line you begin typing. You can begin typing your statement at any position on the line. Okay. Okay, returning to your first C program, you first need to type it into a file. Any editor can be used for this purpose. Unix often uses an editor such as VI or Emacs. Emacs propaganda. C compilers recognize file names that end in 2 of the characters dot and C. C programs, as C programs, I see. So assume you type program 2.1 into a file called prog1.c. Using the GNU C compiler, this can be as simple as issuing the GCC command at the terminal followed by the file name. So if we do that, that should just, work, right? But then now the thing that we're going to have to do is let's see if this works, because I don't know if a.out has execution. Oh yeah, it does. Okay, it can be executed. Nice. There we go. We've officially written a program in C. Let's go. So very nice. You can also specify a different name for the executable file at the time a program is compiled. This is done with the -o flag. Yeah, so that's good. So programs are compiled by specifying the compiler command along with the name of your C program, which ends in .c. By default, this spits out a file called a.out, but you can specify, actually let's make this a new point, a name for the executable object file or object program by using the -o flag. So gcc prog1.c prog1, right? So we can do that as well. And then we can do prog1. There we go. Nice. And then we'll remove a.out as well, just to clean it up. But there we go. Very good. First line of the program should be included at the beginning of just about every program you write. So the first program, line by line. So it's include stdio.h, tells the compiler information about using printf, which is the standard IO library. So int main void informs the system that the name of the program is main. Informs system that the name of the program is main, and it returns an integer value Main is a special name that indicates precisely where the program is to begin execution. So main is a special name to indicate where the program begins execution. And then the parentheses specify function. And that, and void specifies that the function takes no arguments, right? Something like this. I could also do this as a multi-liner as well. Probably should do that actually. Okay. If you're using an IDE, you may find that it generates a template main for you. Now that you've identified main in your system, you're ready to specify precisely where the routine is to perform, or what the routine is to perform. All right, all program statements included between the braces are taken as part of the main routine. We already know all this, right? So we have our printf. I'll just do hello world here. So 3. Let's do this actually on a new line. Calling printf from standard IO, taking 1 argument to then be displayed on the screen. N specifies a new line character such that anything printed after the string are to be printed on a new line, right? Something like this. In fact, the new line character is similar in concept to the carriage return, yes. We already know they all must end in semicolon, and then we'll do our return 0 here. So, tells main to stop executing and return the value 0, which semantically indicates that the program completed successfully without any errors, right? This exit status can be tested by other programs called an exit status. This exit status can be tested by other programs to see whether the program ran successfully. Now that you finish analyzing your first program, you can modify it also to display, and programming in C is even more fun. Very cool, very cool. So let's do that. So we can do a vim prog1.c. So we can do another printf. And we can say programming in C is very fun. then we can recompile that and then run it. There we go. As you'll see from the next program example, it's not necessary to make a separate call to the printf routine. So I could just do it all in one, theoretically, right? So if we wanted to do this all in one printf statement, we could make that work as well. I think this is fine. Oh, okay, it doesn't. Okay, so how do we go to a new line? I guess it doesn't really matter. We can just keep it all in one line. There, that did work. Okay. But how do we actually do that, generally speaking? Multi-line function calls C. Or let's say multi-line printf. Oh, I see. Okay. So we could do it as multiple strings. So if we did this, I still don't know Vim motions, but if we did, hold on, I wasn't in insert mode. Hold on. So if we did this, but then we did this as its own thing. So now this should work, right? And then these will concatenate together, theoretically. Yes. Okay, that does work. Very cool. Okay. Can accomplish, or printf, I should say, can concatenate so something like printf line 1, and then you can do line 2. Line 3. There we go. Nice. So something like this. Pretty cool. As you'll see from the next program example, it is not necessary to make a separate call. Yes. Printf routine is most commonly used routine in this book. This is because it provides an easy and convenient means to display program results. Values of variables and the results of computations can also be displayed. So let's do a prog2 here. So we'll do a include and then we'll say int sum equals 25 plus 50. Printf the the sum of 50 and or 25 and 50 is, I mean, we can use our different numbers here. We can do like 25, 1, 2, 3, and 57, 573,489 is integer, and then we specify that here, right? Like this. So now if we compile this, the sum of 25,123 and 573,489 is 598,612. Nice. Cool. The first C program statement declares the variable sum to be of type integer. So I could actually like separate the declaration in the assignment. So I should actually say that here. I should say declaration and assignment in the same variable, or in the same line of sum. Right? Yeah. Example of integral values are 3, 5, negative 20, and 0. Numbers with decimal places, such as 3.14, yeah, floating points. The integer variable sum is used to store the result of the addition of the two integers 50 and 25. The blank line was intentionally left following the declaration of the variable to visually separate the variable declarations of the routine from the program statements. That's fine. When outputting the results of a computation with printf, you can include a, what would that be called, a placeholder? Percent character inside the first argument is a special character recognized by the printf function. You can include an identifier symbol in the string itself as a placeholder for a value, say an integer. The letter immediately following the percent sign stands for the type of the variable to be passed to printf. type of the variable to stand in for the placeholder, which is specified in the following argument. So for example, we've got like int main void printf say printf 1 plus 1 equals, and then I, and then we could say 2, right? Something like this. Or we'd even say int sum is equal to 1 plus 1. And so then if we want to do multiple values, if you want to output, or let me think about how to do this. To define multiple placeholders, list their placeholders, list the placeholders as subsequent arguments in order that they appear in the string. For example, we've got, if we do another program here, oh, and then this needs to have a return 0 as well. We can do like an int num1 is equal to 1, and then we can do a float num2 is equal to 3.14, and then printf the integer is I, and the float is, I think it's f, right? Float wildcard C. I think it's F. No. Yeah, it is F. Okay, good. And then you do num1, num2. Like this. So that's good. When the printf routine finds the I character, %I character inside of the character string, it automatically displays the value of the next argument in the printf routine. Because sum is the next argument to printf, its values are automatically displayed after the characters. Okay. Yeah, so this is pretty easy too. You got your multiple values. Basically, pretty much what we did here, right? Similar idea. I mean, we could even, you know, these are all integers for sake of simplicity. First argument, commonly called the format string. Describes the system, how the remaining arguments are to be displayed. The value of value 1 is to be displayed immediately following the display of the sum of characters So yeah, they're defined in order essentially. Let's just see how much left we have in the project. So we just have comments, and then we're going to do some exercises. All right, so let's take another 5-minute break. I'm gonna be right back. I'm gonna get some water, stretch my legs, and we'll be back with more C. So we're gonna do another hour, I think, and then yeah. So BRB. All right. I'm back here. Let's just turn that off. Hydrate yourself. Yes, indeed. I do have a glass of water. I had a tea at the beginning of the stream, but I forgot to forgot to get water alongside it. So, yep. That's basically that. So this is pretty easy stuff, but this is good. It feels nice to kind of do relearn the basics, kind of to refresh my C. Return to something that's very simple compared to the complexities of the file uploader project that we're doing. So yeah, I'm thinking instead of you see that the little star icon next to the member. I might replace that with my logo. I don't know if you said earlier, but what editor are you using for this? For this is Obsidian. It's still Obsidian, if that's what you mean. And then you mean for the writing code is Vim. So I'm using Vim to write code, but I'm just using I haven't like learned all the Vim motions or anything. I'm just using it. I know how to use Vim at a basic level. So like for editing stuff, I'm just using Vim and the command line. I hope that this text is big enough for you guys to see. I can zoom in the terminal if needed, but I zoomed it in decent amount. So that's what I'm doing. I have just a terminal open. We're doing it the pure way. No VS Code, because like VS Code is great for like web dev and stuff because there's so much tooling around with it. But when it comes to like just like C coding and stuff like that, like I find like things like Vim or like working like in a terminal editor like more than fine, because like you're usually only working with like one file at a time, generally speaking, unless you're making like a more involved program, in which case maybe NeoVim would be better suited or something, even VS Code, I guess. But I think when it comes to learning C, I think doing it in Vim is fine. That, and I'd like to get better at it. I also want to I have a dot file for it. I thought that's what you said. Vim scares me. Yeah. Vim is confusing. Like I only know the basics, like the very basics of Vim. Like I know how to open it, I know how to close it, and I know the difference between command mode and edit mode. I still haven't really figured out the visual mode yet, because I know there's you can type V and then that brings you into this visual mode to kind of navigate around your files, but I'm still not super good at doing that. Plus the Vim motions, I don't use HJKL as arrow keys. I use the actual arrow keys like a noob, I guess. But maybe we'll do a specific Vim exercises stream at some point, learning Vim. But I know it enough to write programs and save them. So that's basically it. All right, so let's continue. Okay. So comments. The final program in this chapter introduces the concept of comment. A comment statement is used in a program to document a program and enhance its readability. Comments serve to tell the reader just what the programmer had in mind. Yeah, obviously we know we know comments, right? There are two ways to insert comments. A comment can be initiated by the two characters / and star. And then in the comment, the characters star and / are used without any embedded spaces. All characters included between the opening and closing are treated as part of the comment statement. So this we already know. This is kind of basic. Program 2.6, 4 separate comment statements were used. This program is otherwise identical to program 2.5. Admittedly, it's a contrived example because only the first comment at the head of the program is useful. Fair enough. It's possible to include so many comments in a program that the readability of the program is actually degraded. Yes, that's true. I tend to honestly lean on the side of fewer comments. The intelligent use of comment statements inside a program cannot be overemphasized. Many times a programmer returns to a program that he coded perhaps only 6 months ago, only to discover that to his dismay that he cannot for the life of him remember the purpose of a particular routine. It's a good idea to get in the habit of inserting comment statements into the program. Far easier to document the program. I want that to be including that Y. There we go. Comment can not only help you read through the program, of course. I have yet to discover a programmer who actually enjoyed documenting a program. In fact, after you finish debugging your program, you'll probably not relish the idea of going back to the program to insert comments. So that makes sense. Now you should have a good feel as to what is involved in writing the program, and you should be able to develop a small program on your own. In the next chapter, you'll begin to learn some of the finer intricacies of this wonderfully powerful and flexible programming language. All right, so the first exercise I'm going to skip only because it's pretty trivial. Type in run the 6 programs presented in this chapter. Compare the output produced by each program with the output presented after each program in the text. I mean, that's just copy and code. I think we can go over that. So let's say, let's do our exercises here. So we'll make a new, we'll go back out here, or maybe we'll make a new folder, exercises, and then cd into exercises. And then we'll do maybe, we could do, should we do Mictor chapter 2? And so it's chapter 2. Or even just, we can just call it 2 actually. And then we'll do vim 2 or exercise 2. dot C 2-2. That's fair. It's kind of like Mario levels. Okay, so let's do this. So so we'll say in C, lowercase letters are significant. And then we'll do main is where program execution begins. Opening and closing braces, close programs, program statements in a routine, and all program statements must be terminated by a semicolon. Very good. Then we'll compile this. Missing terminating. Oh. Ah, yes. Okay, that is true. Let me insert, please. Thank you. I think there's a way of going to the end of a line in Vim. I forgot how to do that. Vim, go to end of line. Oh, $ key. Right. Makes sense. Similar to regexes. Okay. Okay. Very good. What output would you expect from the following program? So I'll just do vim x 2.3. And then we'll do it as like a .text. And so the output would be testing ... 1 2 3 4 1 1 2 3 2 1 2 3 and then new line like this. Write a program that subtracts the value 15 from 87 and displays the result together with an appropriate message. Okay. Oops. So we'll say, we could say int num1, num2, sum, or difference. And then we'll say num1 is equal to 15, num2 is equal to 87, and difference is equal to num1 minus num2. Printf the difference between, we'll do D, and D is D. And then new line, and then we'll say num1, num2, return 0. We'll do our compiler. Good, good, good. The difference between 15 and 87 is negative 72. Nice. Identify the syntactic errors in the following program, then type in and run the corrected program to ensure you've correctly identified all the mistakes. So we'll do vim exercise 25.txt, and then so we'll do mistakes. So line 3. Void should be void, not capitalize. Line 4, bracket should, or what would I call this? Should be opening a French bracket, not this. Line 5, int should be int, lowercase. Line 7, closing comment tag should be this. And go after or no, actually this is wrong. Line 5, then I'm going to do line 6. Comment should be single line. Remove erroneous closing comment tag on line 8. Then we'll say line 8 comment should start with the 4 display results, of course. Line 9, we'll say printf needs comma between format string and some variable, right? I think that's all the mistakes. So we should be able to write that no problem. Oh, and there's also should be no space between printf and the bracket, probably. Look at this double typing problem. It's so annoying. Okay, that's good. Then we'll compile this guy. Ah, semicolon. Ah, that's another one I missed. So line 7, semicolon, missing at end of some definition or assignment. Right? Okay, so good thing the compiler is nice enough to tell us that. Okay, now this should compile properly. Good. Nice, the answer is 43. Very good, very good. Exercise 2.6. What output may you expect from the following program? Oh wait, I'm still in highlighter mode. Include, let's see, insert int answer result. Answer is 100, result is answer minus 10. The result is 95. I think this will say 95, right? Because the result is 100 minus 10, which is 90, and then you're adding 5 to the result, so the result's 95. So that's pretty easy. We could even prove that by writing it out. Answer results doesn't really matter. Ans is equal to 100, and then result is equal to answer minus 10. Printf. The result is right. So we can do that. And compile it, and then it should be result is 95. Very good. Cool. That's that. Very simple, but you know, still cool to run through those. Kind of de-rust a little bit here. Variables, data types, and arithmetic expressions. Say types and expressions. Okay. True power of programs you create is in their manipulation of data. In order to truly take advantage of this power, you need to better understand the different data types. Of course, int, float, double char, and bool. Modifying data types is short, long, and long, long, which like change the, I think the number of bytes that you can use inside of each, right? Like I think. Is a default int in C a signed 32-bit integer? I think it is. I think that's true. And then a short is 16 bits, and then a long is 64 bits. I'm pretty sure. And then a long might be 128. I'm not sure. Rules for naming variables, and then typecasting. Very good. Not the long. What even is that? Let's see. C long. Is it 128? Signed long. Oh no, it looks like 64-bit. I see. Oh, so base int is only 16, and then short is. Oh, so a short is 16, and then a regular int is 16, and then a long is 32, and then a long 64. Yeah. I didn't know that. I didn't know a basic signed integer type was only 16 bits in C. I did not know that. It's actually good to know. I thought it was 32 by default, but that makes sense. But yeah, so you have already been exposed to C base data type. So let's see. Okay, so let's say understanding, so data types and constants. As you recall, a variable declared to be of type int can be used to contain integral values only. C programming has 4 other basic data types. 4 are primitive data types in C. So we have int, float, double, char, and bool. Why is it like this though? Underscore bool. A variable declared to be of type float can be used for storing floating point numbers. So float, store, decimal, point, numbers. And of course the encodings, you know, you've got like the whole, there's the sign, and then I think it's like the sign, mantissa, exponent or something, or is it exponent mantissa? I don't remember the order of that. That's something I'm digging this up from like my OS class. The double type is the same as the type float, only with roughly twice the precision. Double, same as floats, but with twice the precision, right? And the char, store single character value. We'll store a true or false. Or 1 or 0, I should say, to be more correct. Variables of this type are used for indicating an on-off, yes, no, or true-false situation. And C, any number, single character, or character string is known as a constant. Any number, single char, or string is known as a constant. Expressions consisting entirely of constants are constant expressions, e.g. 128 plus 7 minus 17. Yeah, so that's fine. The integer type. Or just say integer type. Integer constant consists of a sequence of one or more digits. Okay, this is all very obvious. No embedded spaces are permitted between the digits. Two special formats in C enable integer constants to be expressed in base other than decimal. Which is the default. And then so we have our octal, base 8. Integer value can be displayed at the terminal in the octal notation by using the format characters O and the format string of a printf statement. To display an integer as an octal, can use the %O symbol or placeholder in a string or in a format string. And then that's good. If an integer constant is preceded by a 0 on the letter X, hexadecimal, base 16. If an integer is defined with a preceding 0x that defines the value as hexadecimal. I don't know why that defaults to 15 minutes. That's okay. Compose of the digits 0 to 9 and A to F. So an example would be what? Integer color equals 0x FFEF 0D. Right? Cool. I think that's in my settings actually where I can change that. Yeah, and long break interval is 6. Okay, let's take another 5-minute break, and then we're going to do one more Pomo, and then that should be it for today. Just kind of skimming through this. Let's see how long this is. It's quite a lengthy chapter. This is very, very in-depth, I will say. Then we've got our exercises. Very cool. Boolean integer. There we go. I gotta go now, but this was super productive, and I'm looking forward to the future ones. I appreciate that, Marco. Thanks for coming around. Yeah, again, if you guys want any suggestions for future members only streams, I would greatly appreciate it. I know this is kind of like kind of just like a study session, whatever what have you, but I hope there's value in my process. But yeah, that's kind of what we're doing here. So. I don't know. I think this has been really productive, to be honest. And I think it's also good for if you want to learn C and you want to kind of follow along, and you've never had any exposure to it, or like if you've only done like Python or something and you haven't really had exposure to kind of these lower level. And I said C was higher level, but like these kind of lower level concepts. I'm actually gonna make these as headings, I think. But yeah. I don't know if it even says like, do I get stream statistics? I guess I do. Okay, cool. 7 views, wow. I don't even know how that's possible. You know what though, I will say, in comparison to doing like, to doing public streams, like this is a lot more chill, and I do like this vibe. So. Hold on just 1 second. All right, we're back. I think if you click off and back on, it counts as an additional view. Yeah, that's true. It does. It does. And I will get. I think if someone joined membership, I would get a ping, an alert. So I gotta. Yeah, I think I just gotta like. The thing is I gotta get better at like advertising. Or even like not even advertising, but just like. I don't know. Providing a service, not even a service, but just like something that people would, pay however much it is per month. I think I set it to $6 Canadian. I was gonna do $8. I'm like, nah, maybe that's a little too expensive. So I think $6 Canadian. It's about like, I think $4.50 US or something. I think that's reasonable. Cause I mean, like we pay for subscriptions, to various things that are, I feel like that's about the value. Because if I do like 4 streams, you know, 4 member streams a week or a month, and you know, about $1 per stream, something like that. I think that's about fair. But I wish there was a way to, like, I don't know, to, like, in the future, if I ever did raise the price, to keep the price what it is for the original people that signed up. I don't know. I'm kind of getting ahead of myself a little bit, considering we've only got like 4 members. But future streams, we could do a project where the members can pick different features of what have you. Yeah, exactly. And again, this was just kind of like an inaugural stream, just to kind of like get the process started. And kind of the other thing too is like to have a stream on my channel so that people would say, hey, look, like he's doing members only streams, maybe I should get into that sort of thing. Like, because right now it's not very clear like what I'm offering for membership to a viewer that's uninitiated, right? So I'm hoping to establish this to sort of maybe as a bit of an incentive to join. So yeah, and maybe I'll also make a video too, a dedicated video discussing it once we get a few more members, and we do some, like, you know, maybe like a project sharing stream or something like that. So anyway, I'm gonna do one more session, and then I'm gonna end the stream for today. But I think it was a success, I would say. I mean, you guys showed up. You know, I really appreciated that, and you know, so yeah. And again, like even with members only streams could be good for, like, if you need 2.5 hours to just work, like you can just work alongside me, whatever. I mean, you can use the regular streams for that too, but yeah, I do like how chill it is. So let's get back into it here. Okay, so we've got our octal, and the octal's good. I don't know if you know file permissions, but you've got octal definitions of file permissions. So like you can see, for instance, that like so this defines the file permissions for each thing, right? So I think this is like the user that created it, the group, and then global, and these are different flags like RWX, read, write, execute permissions, right? So this is like the user can read, write, or execute this file. Anyone in the group can read or execute the file, and anyone on the entire system can read or execute the file, right? But you can represent these 3-digit binary numbers as octal values, and often they are. And if you use like the chmod command, you can like modify the file permissions based on, 3 octal numbers representing these 9 binary digits, right? So that's, I think, the main use for octal, at least that I learned in my degree, from what I remember. So yeah, and then so format in what was I say? Format in or placeholder in format string for hexadecimal is X. Or to show leading 0x. Cool. And then you can also do a placeholder to lists A to F digits as capital letters. It's pretty cool. Storage size and ranges. So let's see. Every value, whether it's a character, integer, or floating point number, has a range of values associated. This range has to do with the amount of storage that's allocated to store a particular type of data. In general, the amount is not defined in the language. For example, an integer might take up 32 bits on your computer, perhaps it might be stored in 64. Interesting. Okay. So it actually isn't specific. So what an int stores in C is actually dependent on the machine. That I actually did not know. That amount is not defined. The amount an integer stores is dependent on the machine, not the language. Yeah. For example, an integer might take up 32 bits on your computer, or perhaps it might be stored in 64. You should never write programs that make any assumptions about the size of your data types. You are, however, guaranteed that a minimum amount of storage will be set aside for each basic data type. For example, it's guaranteed that an integer value will store a minimum of 32 bits. Okay, so that is true. It is 32 bits. Integer types on, or integer variables in C can store a minimum of 32 bits, or 4 bytes, right? So there we go. So floating point type. The variable is declared to be of type float, can be used for storing values containing decimal places. A floating point constant is distinguished by the presence of a decimal point. You can omit digits before the decimal point or digits after. So denoted by presence of a decimal point. Digits or numbers can omit digits before or after the decimal, but not both. Uses the flag %f in format strings, like placeholder. Floating point constants can also be expressed in scientific notation. This I did not know, actually. I mean, I knew this is how like they're represented in the actual computer, but I didn't know you could. I guess it makes sense that you can do that. Value 1.7 e to the 4 is a floating point value expressed in this notation. It represents the value 1.7 times 10 to the 4. So the 1.7 is the mantissa, and then the 4 is the exponent. Representing the power of 10 by which the mantissa is multiplied by. The exponents can be positive or negative. So 2.25 e negative 3 would be the equivalent of 2.25 times 10 to the power of negative 3, or 1 divided by 2.25 times 10 to the power of 3, right? Incidentally, the letter E, which separates the mantissa from the exponent, can be written as either lowercase or uppercase. Uses placeholder E to express or display float in scientific notation. Printf format characters G can be used to let printf decide whether to display the floating point value in normal floating point notation or in scientific notation. This decision is based on the value of the exponent. If it's less than -4 or greater than 5. Oh, I see. Use /g to let the compiler decide whether to present value as float or scientific, or decimal as decimal value or scientific notation. This is kind of cool, actually. So if exponent is less than -4 or greater than 5, then the value is displayed in scientific. Otherwise, decimal value. Interesting. That I did not know as well. Hexadecimal floating constant followed by one or more decimal or hexadecimal digits followed by a p. Express hex floats with scientific notation using p. So 0x 0.3 p to the 10 is 3 divided by 16 times 2 to the power 10. Notice how the exponent is to the power of 2, or whatever, is 2 to the power. How do I say this? The base of the exponent here is 2, not 10. Yeah, so that's another important thing to consider, right? Okay, extended precision type double. Double is very similar to float, but is used whenever the range provided by a float is not significant, or not sufficient. So can store approximately twice as many significant digits as can floats. Unless told otherwise, all floating point constants are taken as double values by the C compiler. Are assumed to be doubles, or taken to be doubles by the compiler. Right? Display double value, the format characters F, E, and G. Uses the same placeholders for display in format strings. Single character type. Defined by enclosing character in single quotes. Do not confuse a character constant, which is a single character enclosed in single quotes, with a character string. So a character constant is fundamentally different than a character which are multiple, which is a string of multiple characters enclosed in double quotes. Right? And I think, I'm not 100% sure on this, but I think in C, I think a string like in the, in the program is actually just represented as an array of characters, yeah. So, special character constants. /n is a valid character constant despite consisting of two symbols. The backslash character does not count as a character in C as it is used to denote the beginning of a special character. And I think to denote a backslash in C, you actually have to do this. To actually denote the backslash character in C, you have to the format I think it's double backslash, right? Let's find out. Because these are escape sequences. Yeah. This issue is solved by using two backslashes to mean one. Yes. Very good. Okay. Format characters, yeah, so the flag uses the placeholder C to display and format strings. Character values, I should say, really. The Boolean data type. Just stores the value, just stores one bit, 0 or 1, but the precise amount of memory used is unspecified. Yeah, I feel like you would have to use at least a byte, right? Like bools in C. Like I don't even know how much it actually stores in the memory, right? The C99 standard of C has introduced the standard bool.h header file. Contains the definition of the bool type, which actually is a type def alias for bool. Okay. How are booleans stored in C? We're getting kind of low level at this point. I'm just curious. Yeah, the compiler could choose to store them all as bits within a single byte. Ah, I see, okay. In an abstract machine, a bool object must be at least 1 byte unless it's a bit field. Okay. If you print the value size of bool or size of 10, the result will be at least 1. Yeah, like you can't like have a fraction of a byte. That makes sense. By convention, 0 is used to indicate a false value and 1 indicates a true value. That makes sense. We already know this. So import library or package, I guess it would be library standard bool.h that defines the bool type. Import header file, I should say. That can be worked with as specified in a C program, right? So that's good. So let's actually like write out this program. So we'll do cd backback. We'll do vim data types dot c, and then we'll say include standard io.h and include standard bool.h. And then so we'll say int integer var is equal to 100, float floating var is equal to 331.79. I guess we'll kind of line all these up, yeah. Double var is equal to 8.44 E11. Char variable is equal to W. Bool var is equal to 0. Printf, say int equals I. I'm going to do this all in the same printf statement. Float is f, and then double is E. Double is G. Character is C, and boolean or bool is equal to I, because it is at the end of the day an integer, right? And then so we're going to do integer var floating var double var char var and bool var, right? And return 0. So that's good. And then we'll compile it. Integer var, what did I forget here? Oh, the comma, of course. There, that should compile now, yep. There we go, so we have integer, 100, float. Oh, I forgot a new line character here. Recompile. There we go. So we have our int, our float, which has a little bit of funny precision there. Precision error due to the way that it's you know, floats are encoded. Our double, and then our truncated scientific double here, and then our character and our boolean, which is cool. So you can see in the second line of the program's output, notice that the value of 33179, which is assigned to floating var, is actually displayed as this. In fact, the actual value displayed is dependent on the particular computer system you're using, which numbers are internally represented inside the computer. You've probably come across this same type of inaccuracy while dealing with numbers in your pocket calculator. Yeah, so certain floating point numbers cannot be exactly represented inside the computer's memory. The E characters are used to display the value of float or double variable in scientific notation. Once again, 6 decimal places are automatically displayed. So this is actually kind of good. So yeah, G automatically, you get that automatical removal of trailing zeros. So there we go. So that looks pretty good. I mean, I think we covered a decent amount of ground. I mean, we're on page, what, 49, page 50 of 1200, but I mean, we'll get there for sure. You know, it's good to kind of go through the fundamentals again. I kind of miss, you know, these sorts of things, and I think it's good to kind of start from this point and you know, re-solidify what I had learned. So, I mean, that's I think gonna do it for the members only stream. I know it was kind of quiet, but you know, I hope there was some value in this. Kind of my process, my note taking style. I kind of almost like. The way that I do it is I kind of almost like lecture as if it's like I lecture to myself using the textbook. Like I kind of make it more interactive through the note taking, and I kind of try to like work with the knowledge as I'm reading it, instead of just statically reading it and you know, letting it kind of, you know, go in and out, right? Because I feel like taking notes while reading, and some may argue that definitely valuable. I appreciate that. Yeah, so like, but some people, you know, what was I going to say? You know, say that handwriting notes is valuable, and that's fine. I don't anymore, but I think still working with the knowledge and kind of manipulating it as you're reading is crucial, and like kind of writing these examples out, right? It's like, sure, you could say you're just copying the code, but it's more than just that, because you're doing it for yourself and you're going through the motion of writing it and, you know, doing that. So anyway, I don't know if we'll do another C stream next time, or, you know, we'll see if folks have suggestions, but, you know, the C streams will definitely come back. I might integrate them. I might do them publicly at some point, maybe when we make a little bit more progress, that sort of thing. But, you know, I appreciate each and every one of you for showing up and and taking time out of your afternoon or evening or wherever you are to join me. So I really appreciate that. And yeah, I think the format of one member stream a week is going to be what we're going to do going forward. I think it's good. And so yeah, so stay tuned for the next one. And I'll see you all later, and I hope you have a fantastic rest of your day. So.